Okay, so now that we can use Pythagoras to work out the length of a hypotenuse, we can use it to work out the length of any of the legs by subtracting, remember. We can now look at how we prove that a triangle is right angled. Okay, now remember, Pythagoras' theorem works for right angled triangles and right angled triangles only. Okay, so if we are to prove a triangle right angled, we can test it using the theorem of Pythagoras. Alright, and that's what we're going to do just now. Now, if we look at this triangle here, and we're asked, is it right angled? Is this triangle right angled? And we've got one side's 8 centimetres, one's 6 and one's 9.95. Now, that is very slightly different to one of the triples that you know, the 6, 8, 10 triangle, but we're going to test to see if Pythagoras' theorem works with this triangle here. Okay, so remember again, copy this into your notes jotter, okay, and we'll go through it, and remember you can rewind me if you want to, and we'll try and prove that this triangle is right angled or prove it's not. Alright, so what we're going to write down first of all is by the converse of Pythagoras. The reason why we do that is because we want to show the marker that we're using Pythagoras' theorem, but we're kind of using it in reverse. Okay, it's nothing to do with Pythagoras' trainers, right? We're using the theorem in reverse. So we're going to start off by using the letters of the theorem. So a squared plus b squared equals c squared. Remember, a and b are the legs, and c is always the hypotenuse. So if we put in the numbers, substitute them in, we're going to get 6 squared plus 8 squared equals 9.95 squared. And that should work if the triangle is right angled, okay? So if the triangle is right angled, then 6 squared plus 8 squared will equal 9.95 squared. Okay, now we're going to try that out. So 36 plus 64 should equal 99. And if we check that out, this gives us 100, and that's obviously still 99, and that's not equal. So we put a cross through the equal sign because it's not equal, and then underneath that we can write that it's not right angled. And the reason why it's not right angled is very, very simple, because Pythagoras' theorem only works with right angled triangles, and if we don't have a right angled triangle, then the theorem will not work. Okay, so we've tested this triangle with it, and we've found out that 6 squared plus 8 squared does not equal 9.95 squared, therefore the triangle isn't right angled. Okay, you will be asked, you'll be given a triangle with 3 sides, and you will be asked to prove that it's right angled. So you will have all the 3 measurements of the sides, and all you have to do is you have to substitute them into your Pythagorean theorem. Remember that C should always be the hypotenuse, as we've shown here, and then after you've worked everything out, be able to see whether or not the triangle is right angled or not. This one isn't, okay, so at the bottom we write it's not right angled. So next day in class what we're going to look at is proving triangles are right angled and how we can actually talk about that, and how we can look at it in a more problem solving context, and how you would use this in kind of real life. Okay, so thank you very much for watching. Remember and copy this into your notes, and we'll see you tomorrow.